talking about graphing polynomials and kind of all of the key features of a polynomial. So a polynomial is a monomial or the sum of two or more monomials that are called terms. And the degree of a term with one variable is its exponent, and all exponents are whole numbers. So standard form of a polynomial lists the terms by degree in descending numerical order. And for each degree, all the like terms need to be combined. So if everything is in order, my leading coefficient is going to refer to that coefficient that is in the front with the greatest power of x. So in this case, the leading coefficient would be 4. And the degree of the polynomial is the greatest degree of any of the terms. In this case, that would be the degree of 4. So if we have one term, we call that a monomial. If we have two terms, we call that a binomial. And if we have three terms, we call that a trinomial. All right, if you have more than three terms, like let's say you have 4 terms, that's just a polynomial with 4 terms. We don't have any way to name, we don't have a name for a 4-term polynomial. So we just call it a polynomial with 4 terms. So if I had 5 terms, it would just be a polynomial with 5 terms. All right, when it comes to the degree, if you have a degree of 1, that's considered linear. If you have a degree of 2, that's quadratic. If you have a degree of 3, that's cubic. If you have a degree of 4, that's quartic. A degree of 5 is quintic, and that's all the special names I'm going to give. There's a couple more, but we're going to leave it at that. If you have a degree bigger than 5, let's say 6, you're just going to call that a 6th degree. If you have 7, it would be a 7th degree, so on and so forth. So we are going to write the polynomial in standard form and use it to identify the leading coefficient, the degree, and the number of terms, and then we're going to actually name it. So first, I need to make sure that these are in order. I have 3 terms. The degree of this first term, since x has a power of 1, is 1. This doesn't have an x. You could think of it as x being to the 0 power, so the degree of just a constant is 0. And then this last one is a degree of 3. So my 2x to the third needs to be listed first, and then my negative 4x, and then my positive 9. So I have a leading coefficient of 2. I have a degree of 3. And now I need to say how many terms I have. I have 3 terms. 1, 2, 3. So since I am naming it, I'm going to start with my degree. The degree is 3. When I have a degree of 3, we have a special name for that. That is called cubic. So you always start with your degree. So I have a cubic, and then I'm going to look at my terms. My terms, I have 3 of them. A name for a polynomial with 3 terms is a trinomial, so this would be a cubic trinomial. All right, so if I look at number 2, I have a degree of 5, 6, 4, 1, and 3. So I have 2x to the 6th first. Then we have a positive x to the 5th, a negative 3x to the 4th, a positive 4x to the 3rd, and then a negative 8x. Make sure you're paying attention to the sign that's in front of your term. So your leading coefficient is 2. Your degree is 6. And as far as terms go, you have 1, 2, 3, 4, 5 terms. So we're going to start with our degree. We don't have a special name for the 6th, so we're just going to say 6th degree. And then I don't have a special name for 5 terms, so we'll just say polynomial with 5 terms. So a polynomial is a function whose rule is a polynomial. The end behavior of a graph describes what happens to the function values as x approaches positive infinity and negative infinity. You can think of this as the right side and the left side. And then this little arrow means approaches. So as x approaches positive infinity, which is the right side, and negative infinity, which is the left side. So you're going to look at your degree and you're going to look at your leading coefficient. So if the degree is odd, that means that the ends of your graphs are either going to be down on the left and up on the right, or up on the left and down on the right. So look at these right here. All of these have an odd degree. I have a degree of 1, a degree of 3, and a degree of 5. Do you see how on my red graph, I'm starting at the bottom, going down, and on the right, I'm going up? Look at your blue graph. Down on the left, up on the right. Green graph, down on the left, up on the right. Okay? This is also an odd degree. 1, 3, 5. These are exactly the same, except there's only one difference. And if you look at these graphs, these are starting going up and ending going down. Starting going up, ending going down. Starting going up, ending going down. The difference is the leading coefficient. When the leading coefficient is positive, okay, it's maybe easiest to look at this with the linear equation. It has a positive slope. In other words, it goes up from left to right. Okay? Or you could think of it as ending on a positive note. Okay? If the leading coefficient is negative, it's going to end on a negative note. It should start at the top and end at the bottom and kind of have negative slope. All right? When the degree is even, 2, 4, 6, 8, 10, all right, that means that we start and end in the same location. So we either start going up and end going up, or we start going down and end going down. So if you look at all these, we're up on the left, up on the right, up on the left, up on the right. Okay, here, down, 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 down. Okay, so if it's even, your degree, you're going to look at your leading coefficient. If your leading coefficient is positive, they will both be up. And if it's negative, they will both be down. All right, so what we are going to do now is we're going to use that leading coefficient and the degree to determine the end behavior. So let's start with our degree. Our degree is 6. Now you want to make sure that everything is in order. It is. The degree of 6, which is an even number, which means that I'm either going to be up and up or down and down. I have two options. So when my degree is even, they're either both up or both down. So that means I'm going to look at my leading coefficient. My leading coefficient is 2, and that's a positive number. So that means that both will be up. So this is how we're going to state this. As x approaches negative infinity, your y value, which I'm just going to call f of x, approaches something. And as x approaches positive infinity, your y value is approaching something. All right, this is where the little, up and down arrows that we've circled come in. This statement stays the same. All right, it is not changing. That stays the same. The only thing that changes is what your y value is doing. So remember, you can think of this as the left side, and you can think of this as the right side. On the left side, we are going up. So the y values are getting more positive. All right. On the right side, the y values, again, going up, getting more positive. And we can actually demonstrate this by graphing. So let's say that we graph this. We have 2x to the 6th minus 5x to the 5th plus 6x to the 4th minus x to the third plus 4x squared. Oop, don't do what I did. Make sure you pop out of the top every time. Plus 4x squared minus x plus 1. All right, and let's graph that. All right, as you can see, up on the left, up on the right, and I'm going to change my table so that it will automatically ask or automatically fill in my thing. And I want to point this out. As the x's are approaching negative infinity, in other words, as my x's are getting more and more negative, look at your y values. Your y values are getting more and more positive. So we have positive infinity. This is kind of a visual thing. As my x's are getting more and more positive, my y values are also getting more and more positive. So as x approaches positive infinity, my y is also approaching positive infinity. So if you kind of need that little visual through the table, just make sure that it's picking its own values there for you. All right, so I'm in order on number 4 already. My degree is 3, which is an odd number. So I know that I'm either going to be up and then down or down and then up. They're going to be odd, okay, not even. My leading coefficient is -5. So since I have a negative, I'm going to end on a negative note. So it's going to be this one, kind of makes a negative slope here. So remember, your statement is the same. As x approaches negative infinity, y approaches something. And as x approaches positive infinity, y approaches something. So remember, you can think of it as left and right. On the left side of the graph, y is going more positive. And on the right side, it is going more negative. Number 5, we are in order. Our degree is 5, which is an odd number. So I'm either up and then down or down and then up. My leading coefficient is -1, which is negative. So we'll end on a negative note. So as x approaches negative infinity, my y value approaches, look at the left side of your graph, positive infinity. And as x approaches positive infinity, my f of x is going to approach, okay, think right side of the graph, it's going down, so negative infinity. Number 3, my degree is 3, which is odd. So again, we're either up and then down or down and then up. And my leading coefficient is 1, which is positive, so we'll end on a positive note. So as x approaches negative infinity, my y value approaches, now remember, left side, it's going down, so negative infinity. And as x approaches positive infinity, my y value approaches, look on the right side, positive infinity. All right, a point where the function has the least value over an interval is the relative minimum. A point where the function has the greatest value over an interval is called your relative maximum. And points where the function values change from increasing to decreasing or vice versa, those are called your turning points. So we're going to use a table of values to identify key features and sketch this graph. It's not going to be perfect. And then we're going to find the average rate of change over a specific interval. Now, I've made this table. These are just numbers that I chose, okay? They're not anything special. I just chose these x values. So we're going to use our calculator to fill in this table. So grab your calculator, go to your y equals, and we're going to plug in -0.5x to the 4th plus 3x to the 2nd plus 2. Now I'm going to go ahead and go to my table setup menu, and I'm going to change that independent to ask because I want to fill in my own table. So now I'm going to go to the table, second graph. Okay, and I'm going to fill in my table. So I have -3, -2, -1, 0, 1, 2, 3. And I'm just going to fill those in my table. So -3, I have a -11.5, 6, 4.52, 4.56, -11.5. So, I mean, we already saw what the graph looked like, but we're going to pretend we didn't see it, okay? So if I go from -11.5 to 6, that means I'm increasing. I'm going up. But then I start going from 6 to 4.5, and that means I go down. So from here to here, I am increasing. And then I go from 6 to 4.5, and 4.5 to 2, and then 2 to 4.5. So from 6 to 2, I am now decreasing. So we have a period of increasing, and then we have a period of decreasing. So now from 2 to 4.5 to 6, I'm increasing again. So at some point I turn and come back up. And then from 6 to -1.5, another period of decreasing. So I have to turn and go back down. So I should have one minimum, and I should have two maximums. Well, if I'm increasing and then I decrease, that means that somewhere in between, I have a maximum. And then if I go from decreasing to increasing, somewhere in between, I have a minimum. And then increasing to decreasing again means I have another maximum. So I should have two maximums and a minimum. And if you remember looking at the graph, we did have two high points and one low point. So let's talk about those turning points. Turning points are where we're going to have the mins and the maxes, somewhere in between something. So I know that I have a turning point. I have turning points when x is near here, here, and here. Those periods where we stopped increasing and started decreasing, or stopped decreasing and started increasing. So that means that when my x's are around -2, 0, and 2, I will have turning points. So think of this as well. Your end behavior. As your x value approaches -infinity, your y value has to be doing something. And as your x value is approaching +infinity, your y value has to be doing something. Well, think about this. We're even, so it's either both up, both down. And it's negative in front, so that means that both are going to be down, the left side and the right side. And if you look at that on the graph, you are down on the left, down on the right. All right? Now, let's go ahead and graph these points. So we have -3, -11.5, which would be about right there. -2, 6. -1, 4.5, 0, 2, 1, 4.5, 2, 6, and then 3, -11.5. Now, you kind of almost want to make this curve at these points because they're the highest points. But that's not what we want to do because those are not the maximums. The maximum is somewhere in between here, because I started increasing and then started decreasing. So between when x is -2 and x is -1. So when you're drawing this in, somewhere in between when x is -2 and x is -1, it comes up and then it starts going back down. Now this is actually your relative minimum right here at 0, 2, but it curves back up. And then between 1 and 2, again, it reaches a maximum and then comes back down. And hopefully you guys can draw that better than me. So there's a general sketch of the graph. Okay, is it perfect? No, it's not going to be. We're just giving a rough sketch. Now, did tell me to state my relative mins and maxes here. So we have a relative maximum in two locations. So we'll say near. Well, I know that it's near this point and it's near this point. So I'm going to name those points. That would be the point negative 2, 6 and the point 2, 6. Then we have a relative minimum near the point 0, 2. And again, we have already named all of these when we looked at our table. Okay, and last but not least, it asks for the average rate of change. That's where we kind of use slope formula. And you subtract your x's on top and y's on bottom. It does do f of b minus f of a in our textbook. That literally just means if these are the x values, I would plug those into my equation to get the y values. So you can just think of it as y's on top, x's on bottom. Well, they gave us an interval from negative 2 to 0. So these represent x values. An x value of negative 2 to an x value of 0. Well, when x is negative 2, I know that my y value is 6. And when x is 0, my y value is 2. So now I'm just going to use that slope formula. I'm going to do 6 minus 2, y is on top. Now if I use 6 first on top, I have to use negative 2 first on bottom. So negative 2 minus 0, and that's going to give you negative 2. So the average rate of change over this interval of negative 2 to 0 is negative 2. So that's the average rate of change. It's not the actual slope, it's just the average over that period. All right, so we're going to do the same thing on this one. So we're going to grab our calculator and plug that equation in. So we have x to the 5th plus 18x squared plus 10x plus 1. All right, now I do want to point this out. 5 was an odd degree, so we're down and then we're up. And because the leading coefficient is positive, we will be ending on a positive note, so we'll be down and then up. The numbers for my table are the same, and they are already over here, so I'm just going to fill in my table. So I have negative 3, negative 110, then 21, 8, 1, 30, 125, and 436. Now, obviously, these are not all going to fit on our graph. We're just going to do a rough sketch here. Okay, so let's go ahead and let's talk about our turning points. In order to identify those, we need to look at these y values. So if I go from negative 10 to negative 21, or that's not negative. If I go from negative 110 to positive 21, and then to 8, I would be going up and then down. So I have from here to here is increasing, but then from 21 to 8 to 1, we are decreasing. And then from 1 to 30 to 125 to 436, this whole rest of the way we are increasing. So if I increasing and then decrease, I have a max. And then if I decrease and then increase, I have a min. And if you looked at that graph at all, you can see that you have a max somewhere up in here, and you have a min right here. Okay. Now, so we have turning points near negative 221 and 0, 1. Or we could have just said near x values of negative 2 and 0. All right. Now let's talk about our relative minimum and maximum. So I only have one relative maximum, and that would be at the negative 2, 21. And then I have a relative minimum at the 0, 1. And then let's go ahead and describe our end behavior. So as x approaches negative infinity, y approaches something, and as x approaches positive infinity, y approaches something. So take a look. You're odd, so you're either down and then up, or up and then down. Since you're positive out front, you're going to end on a positive note. So left side is negative, right side is positive. And you can visually see that on this graph as well. Negative on the left, positive on the right. All right, now we need to talk about the average rate of change. And this wanted you to go from 0 to 2. And remember, those represent x values. So when x is 0, y is 1. And when x is 2, y is 125. This time I'm going to start with this point. So 125 minus 1 over 2 minus 0. That's going to give you 62. So your average rate of change over the interval from 0 to 2 is 62. Now we can graph this and kind of give a little sketch. So just pay attention to how you're counting. All of these lines here are counting by 5s. So if I have negative 3, I can't graph that point. Negative 2 up to 21. And then I have negative 1, 8. 0, 1, 130, and then we have those. So I didn't give enough space on this, but let's pretend here. If I go negative 3, negative 110, that's going to be way, 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 way down this direction, okay? And if I graph 2 and 125, that's way, 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 way up, somewhere up in there. We really can't fit this on our graph. But I do know that between negative 2 and negative 1, this is going to curve somewhere. So if I came all the way from the bottom, let's just pretend we're coming up this kind of skinny. I know that this is the point that was negative 2, 21. Somewhere it goes up and then it curves and comes back down. And if you look visually, it's like way up there. Okay, so this is not going to, you could zoom out if you wanted to. Zoom 3, press enter. Okay, it's going to be it's up here somewhere, and then it's going to come and curve back down. So it's going to come up and curve somewhere. I don't really know where, in between, and then come down and hit. And then I have a minimum somewhere in between the 0 and 1. So comes down, and then it's going to go back up. This is a really terrible drawing. I apologize. I made my graph too skinny, guys. But you get the gist, and you can actually see it on here. Remember, if you ever need to get back to the center, just press zoom 6, and it brings you back to the center. And if you look, I did not go down far enough on my point, probably. I needed to go past 0 and come back up. So, like I said, it's not going to be perfect. It's just going to be kind of a rough sketch. But hopefully, having a calculator is helpful in visually seeing it as it really is meant to be seen.